Everyone, followers of my channel, welcome to today's video. In today's video we will see how to conduct homogeneity test on a hydrological data. So before we have using any data, you should check the quality of your data. So one of the most important tests that you should conduct is homogeneity of your data. So to start with the homogeneity test, let us see some information. Now for today's tutorial we will see the Mann-Whitney methods, or that is MW test, that help us to detect the homogeneity and stationarity of the data. So to check the homogeneity of our data, we should divide your data into two samples, saying P and Q, but this P is should be less than or equals Q, okay, and N is equals P plus Q. It is ranked in increasing order, and R is the sum of the ranks of the elements of the first sample, that is P. Yes, and the other elements are there. Here V equals R minus this one, P. As we have seen, R is the sum of the rank of P, and P is the number of the sample, and W is calculated in such a way, as well as this U bar is calculated by PQ divided by 2. After that you calculate the U critical here. It's not U critical, I mean U is minimum of V or W, and the variance of U is calculated by this one, and here T or J. If there are repeated ranks, you should collect those ranks, and after that you can calculate this T value. Yes, this T value, and T value is simply J cubed minus J over out of T all, okay, and U is here U minus U bar divided by the variance of U, that is a square root of variance of U. And if this U critical, I mean U statistics, we can say, is less than that of U critical, so the data is homogeneous. And if the if the data is not satisfied the condition, we can say that the data is non-homogeneous, and you should back to your data and make some analysis. So to see an example with a homogeneity test, I have prepared this data, but you should prepare the data in such a way, and sorry, this is data. Really sorry for this. Okay, sorry. This is the data what I have prepared, but your data should be arranged in vertical direction in such a way. This is my data. So to conduct this homogeneity test, we need annual rainfall of each year, okay, each year. So let us know the annual rainfalls of this station. Basically this station is Bahardar, okay, this is Bahardar station data, and to start with should select this one, the year, the month, date, and data. This is the data, and this is the daily data. So you should convert this daily data into annual data using a pivot table. So after selecting it, go to this insert and click on pivot table, and I would like to work with in this sheet, so I am saying it as existing worksheet and select one place here. Let us select this cell and say OK. So this is a pivot table. So your row should be year, the row is year, and under value you should drag the data, so this year should be this way, and you get this one, yeah. So as the data here is under value, but this is a count, and you should adjust it as the sum, that is annual rainfall is the sum. So say okay. So this one is the annual rainfall of radar station in each year. So let us copy this to start our work, and this is a year here for our purpose, since it is maybe difficult to conduct. So it is 1990, and this one is a year, sorry, this is a year, and this is the data. Okay, and 1991 here. So we have up to 2020, yes, in such a way. And the data here is this one. Copy this value, copy, and paste here under data, paste, and let us make our data in such a way. This is annual rainfall of Barda. So to start our work, you should divide this year into two parts, as we have seen. One is P and the other is Q, but the total year here is 31 years here, 31 year rainfall data from 1990 up to 2020. Here N is sorry, let us do here, and here N is equals, that is count. Let us count our data here. Yes, our data is, that is total of 31. So let us make our data. The first p value here is 50, and the other is q. Q here is 61.6. So we have p and we have q, but you should say no. You can check the number of this one is p. Yes, this is p. We can see this is p. You can count this one, okay, or just give a value here in number, and you can divide it. Therefore up to this is that is p, and after this is that is q. Now let us determine r. This r is as we have seen before, r is under this. This r is the sum of the ranks of the element of the first sample, that is p. Yes, therefore the sum of the rank of p is, that is r. Now let us do the rank of the data here, that is a rank. Rank here is the rank of the data is done, say equals that the rank of this one, rank of this data from the total data, yeah, from the total data, from the total data, select the all data, comma 1. That means if you say comma 1, that is ascending, yeah, ascending, comma 1. So close the bracket, but this data should be constant throughout our ranking, yeah. So you should make this one as constant, yes, in such a way, then say enter. So this data has a rank of 14. So double click here, and this is a smaller annual rainfall, smaller annual rainfall in 1994. Therefore, this P is R is the sum of the rank of P. This P is from 1 up to 50. Therefore, the sum of the rank of P is that is R. So equals sum of rank of P up to this one. So we have R. We have get this R value. After that, you should determine V. Yeah, V is simply given by this V is V, as we have seen here. V is R minus P into P plus 1 divided by 2. Therefore, using this equation, we can determine the values of P as this one minus P, this one times P plus 1 divided by 2, yeah, divided by 2. So say enter. This is a V value, and we have also another value, that is W, and this W is determined by using this equation. P times Q minus V is, that is W, and so equals P times Q. Here is P times Q minus this W is minus V is, that is W, and yeah, after you determine this one, you should find that of U is, that is the minimum of V or W. So you can say that the minimum value from those two value is, that is U. So enter. As we have seen here, you have calculated this one, and U bar here is P times Q divided by 2. This U bar is P times Q equals this P times Q divided by 2 is U bar, and the variance of U here is variance of is U. Variance of U is given by an equation here. It is P times Q divided by N into N minus 1 times N cubed minus N over 2 minus summations of T, but this T is J cubed minus J over this one, but this J is repeated ranks, yes, repeated ranks. For instance, if you have a repeated rank, that repeated rank is for this case, for instance, if you have a repeated rank here, yes, here is a rank, and if this the repeated rank is, it may be 3, for instance, and if this repeated rank is this rank is repeated, this one is J, this is J, and if this rank is repeated 2 times, so j is 2. Yes, so this t here is t, sorry that for that. And if this rank is repeated 2 times and this t is j cubed, it says, yeah, j cubed minus, sorry, j cubed minus j, this one, divided by 12, yeah. In such a way you can get this t, and have you may have additional repeated ranks. So after that you can sum up this t value, and you can substitute the calculated t value in this place. But let us see our data. Is there any rank that is repeated? Yes, if you have 31 here, from those ranks, if you have 31, for instance, yeah, you see this data has does not have any repeated rank. So is this 31 indicates us there is no any rank. If there is a repeated rank, this 31 is not there, rather the rank may reduces, and that is why this is therefore, and in our case let us say that the sum of this t is 0 in our case. So we can determine the variance of u. Okay, so the variance of here u here is p times q divided by n minus this n into n minus 1 times n cubed minus n over this much. So let us do it. And the variance here is equals, so it has p times q, p times q divided by n is 31 times n minus 1, this minus 1. Yes, close the bracket, and also this should be in one bracket, and times the other formula here is, n cubed minus n over 12, yeah, times n cubed, this cubed minus n divided by this one. But here the summation of t is 0, so we can stop your work here, yeah, such a way, in such a way, then enter. This is the variance of u, u. Therefore, if you have calculating the variance of u, after that you should determine the z statistics here, statistics z, or you can say that z statistics. Okay, z statistics is here given by this equation, or you can say that u statistics, and you have z critical, or that is u critical, and this u here is u minus u bar over the radicals of variance of u. So to calculate this is equals u is this one minus u bar, here is a u bar, and close the bracket here, divided by the square root of variance of u, yeah, square root of the variance of u, close the bracket and enter. You see z is z statistics is this much, z statistics is this much, and okay, and the absolute value of this z, absolute value of z is absolute value of this z, or you can say u is can say this one is u statistics. Let us say u statistics. Let us use this u statistics, and absolute value of this u is equals absolute value of this value, and say enter. This is u statistics. So to say the data is homogeneous, this absolute value should be less than that of the critical value of u, the critical value of u. So this critical value, to determine the critical value, we should first give some significance level. That means you have giving some errors. For instance, if you have if we give, for instance, this is alpha, and let us represent it as symbol. Yes, and this alpha, that is a significance level. Let us say 5%. 5% significance level. This is a significance level. Significance level. That means I have 95% correct. If I have giving this significance level as 5%, I made 5% error. Okay, and that means 95% is correct. That means so this absolute value of u is this much, and to determine the critical u value, you should find 1 minus out of alpha over 2, and we can say this as symbol here. Similarly, symbol, and here equals 1 minus this one divided by 2. Yes, you see, this is 1 minus alpha over 2, and z critical here is I mean u critical here. U critical is u critical is norm inverse of this one, the norm inverse of 1 minus alpha over 2. So say equals normus inverse this one. Okay, normus inverse of this value, and if you click enter, you get the z value, this one. So you say that this u absolute value of u here is if you see this one, this data, this one, absolute value of u is 0.316, while the critical value of u is 1.959. So since the absolute value of u is less than u critical, the data is homogeneous. Yes, so since u statistics is less than u critical, the data is said it is homogeneous. Okay, in such a way we can conduct homogeneity test. I hope it is very simple, and you can try on your data. And for the next video we will see the other methods that help us to conduct logical data analysis. Thank you for watching. Have a nice time.